My name is Mathieu, this is Nod, and we're going to be giving a presentation about Drupal in an offline world. Now, this is a merger of two talks, one of Dev Days and one of Drupalaton, I believe. So we kind of merged the two contents of the talks together, but we just figured out we're going to be very short on time. So if I talk really fast and you didn't get anything and you did want to get that thing I spoke really fast off, you can just yell and ask. All right, let's get this going. So, Drupal in an offline world. We all know loads about Drupal, right? So, this talk is going to be about the offline world that Drupal hasn't really taken any role in yet, or any active role in at least. So, we're going to quickly cover all the things that have anything to do with offline, instant, super fast, and anything between website and apps, and the whole scenario, how everything is evolving in there. So the first one is apps. You all know apps, so go quickly over this. It works with Wi-Fi, it also works without Wi-Fi, and it works offline, online, and it has push notifications and background sync. So these are going to be the icons I'm going to be using throughout the presentation to kind of sketch how everything is in comparison with something else. Now, we know what online means, we know what offline means. They also have a lot of flaky internet connections in between those two. But push notifications, quick recap, is anything your phone makes a sound without it being active in the app, just something has been pushed towards your phone, you get a notification. On every device it's something else. This is now a Skype icon, it's on the icon itself. It can be a mail that comes in when you swipe from above, anything really. Now, so that was push notifications. The other thing apps are really good at is background sync. So for example, you're on WhatsApp, you want to send a message, you say, hey man, you send it off. You don't really care if you have internet or not. You have a little clock icon there on the right that just tells you, okay, we got this. Like, throw your phone in the water, we're probably gonna be still able to send it. You know, whatever you do, we're gonna be able to send it, almost. Even if you close down the app and then a month later you go online for the first time after you sent this message, then the message will be sent. It's like, we got this. Compare this to websites, and websites are pretty crap at the moment. Like, as soon as you go offline, stuff breaks, and then you go like, yeah, this sucks. So, this is what we need to fight up against. This is what I'm going to try to sketch out what websites need to catch up on too. So, the second part is websites. We all know websites. It only works online. That's it. That's all the things I'm now going to say about websites for now. So, the thing that tried to bridge the gaps between websites and apps is Google's AMP. Now, AMP stands for Accelerated Mobile Pages. And how they did it is they wanted to have websites that worked really fast, because loads of websites, they kind of follow the stream of how big the game Doom is every time it gets a new version. So AMP is a way of very fastly throwing web pages at the users. How they do it is by limiting stuff. So they limit loads of things you can't do. All the slow stuff, all the trackers, all the this, all the that. And they kind of invented their own HTML for it. It's not all their own HTML, but they kind of invented loads of tags that they want to use. Oh, let's do this now, or let's use this tag. So they strip everything down and they optimize the shit out of it. So it goes super fast, which is kind of the only advantage I see in this kind of technology. So it is faster, and it's Google's way of ensuring ads on loads of different pages, because every page is going to have an ad, obviously, that you probably won't be able to Google ad block, or just ad block. Now, for who is this technology? It's for news agencies that want to post their pages on through Google, so it's very easily findable through Google, like you see in here, or it's for edge cases. Now lately I've been hearing about e-commerce using it too. Not really sure how that works. Probably you put up products like that, and then you go from the product to another website where you already are 3 steps in the process, instead of first opening eBay and then going through stuff and then finding a product and then going to the next step and then going for checkout. It's probably some shortcut in the process. Now, for Drupal, there is an AMP project developed by Lullabot, and it's for Drupal 7 and 8. So you can use it. Now, next one is very similar. It's Facebook Instant Articles. What is it? The same. It's basically the same, but it's from Facebook and not from Google. React, Angular. So they strip down everything. They limit stuff again. It's not valid HTML, and it's only available inside the Facebook app. So kind of looks like this. You click on something, it's instant. That's what they call it, instant. And again, it's their way of probably ensuring ads and revenue and stuff like that, but why not? It's again for the same kind of clients, new JSTs or other edge cases you might be able to use this for. For example, a client that already is on Facebook. Now, there is a project for this. It's called Facebook Instant Articles, and it's for D7 and D8, which is great. Again, now, first to be covered are basically just badass RSS. That, in my eyes, they're probably a bit more, that's in my eyes the only thing they are. They're probably going to be around for quite some time, but they don't really bridge the gap between anything. They're just super fast. They're like websites on steroids, something like that. Steroids, but very slimmed down versions of websites. Now, next technology is Android Instant Apps. This is pretty cool. So they took the approach from, instead of trying to put websites on steroids, they kind of looked at websites and they thought, okay, websites are pretty cool, websites are pretty strong, they're going to be around for a very, very long time, probably. But the strength of the web is that you can link into everything. And you can link to every page, you can link to every site, you can even link sometimes to sections by anchor points. Now, this kind of works in a way that you have an Android app, it's only for Android. You have an Android app and you split it up into modular parts. So you have, let's say, 10 little parts of one application. Then you can send a link to someone, and then that link can go towards that modular part of the application. You download that little bit of the application, it comes up on your screen, bear with me, you go scroll through it, you do something with that app, and as soon as you close it down, you remove the application. AKA, it's almost a website, isn't it? Now, you also have push notifications. So basically, this is how it works. You get a link, you click on the link, something opens, something gets installed without you even noticing it, and all of a sudden, you have one part of the app. And this example is recipe app, where you only see instructions, for example, of that recipe app. It's pretty cool, but again, very edge case on how this is ever going to revolve or ever going to evolve into taking over the web, I think. Now, cool thing is here you can deep link into apps, but it's only Android, and it's only for clients who already have an Android app. Because you kind of have to refactor your own Android app to make it modular. Now, why is this? You don't have to install, it's super fast, and there's no hassle. Now, it's for companies who already have existing apps. And for Drupal, this kind of makes no sense to talk about. Next up, Appcache. So this is where it gets cool. Now, Appcache is bridging the gap between websites and apps. So Appcache is an extra technology on top of websites that tries to make websites work offline. So now, instead of only having this one little bubble of online, you're starting to get the new bubble, like, oh, maybe websites do work offline. So this was invented 6-7 years ago, really sure. But what it is it's an definable, if that's even a word, I'm not really sure, extra layer of caching in the browser. It's basically you have a file, it says a bunch of things, and you just can say, okay, I want to cache this, and this. And you cache all those things in the browser. And the next time you go onto that page, you already have those things cached. It's pretty cool. AKA, if you have it cached and you don't have your internet connection, if you have everything cached, you have the whole website cached. So you have an offline working website. Now, This is pretty cool because it's supported in all major browsers and it gives offline capabilities. Now, that's the good bit of Appcache. The bad bit is that it has loads of security risks. Loads of security risks because you don't even need HTTPS for it, and it's kind of a blunt hammer. It's like, what was that expression? Nailing jelly to the wall, kind of a thing. It kind of works sometimes, but it's very tricky to get it working because you have very bad control over the caching layer. To clear it, it's super hard. To add stuff through what you want to cache, it's very hard. And to edit anything in that cache is also extremely hard. And it's being deprecated in favor of service workers. Now, I'm going to get back to that in a bit. Service workers is basically the nuclear bomb that's going to fix Appcache, anything that was bad in Appcache. It's going to replace Appcache, it's going to make it a million times better. Now, I was kind of losing what I was saying there. Now, for who is it? It's for simple websites. If you want to use Appcache, Outlook is using it, Google Docs is using it, caching some things, some offline capabilities. And for Drupal, there is an offline app created by Swentel, and it's Drupal 8 only. Now, yeah, the thing is here, you can't clear, add, or edit anything from inside your Appcache, or it's very hard. There was even a case that you could cache the file that defines the cache, which gets you kind of screwed. Now, in come service workers. Still good on time, I think. So, service workers. It's basically the better version of Appcache. Appcache was kind of a, let's try this out if it actually works. Service workers is something really well thought out that's being implemented in every major browser right now. Now, it's even implemented right now in all major browsers except for Safari. I'm going to get back to that later. But this is pretty cool because this technology allows you to have super fast websites. You cache everything offline, so basically your page becomes instant as fast as the page can go because your browser still has to process all the files. You have push notifications and you have background sync capabilities with this technology, which is, it's no difference between this and apps, which is kind of the whole point of, this is going to be technology that's going to stick around for a very long time. It's probably going to be the doom for apps in my aspect, or in my regards, how I see it at the moment at least. Now, technology works for HTTPS only, basically because they learned from Appcache. They also, it's progressively. So it's in a weird way that we now have to think about websites, and the next progressive enhancement is the internet. So an internet connection is a progressive enhancement because your website kind of, if you ever went to that website, it's going to work offline. But if you go to that website again, that's nice if you have internet or not. Which is kind of a weird way to think about it, but that's the whole offline capability. It's the same thing with an app. If you open up an app without internet, it's not going to be having the blue bar on top, like annoying the shit out of you by just, is it almost there? Like, you know, like the blue bar that keeps on going without you having internet and you're not really sure if you have internet, but your Wi-Fi is turned on. Flaky internet. I think one of the Google guys called it, Li-Fi. Li-Fi. Pretty good one. Now, Nod is going to cover this later, how all of these things work with a web app manifest. And conceptually, how it works is you have a browser and you have a server, for example, and the browser asks, okay, I want 100 files. I want 25 CSS files, 20 JS files, blah, blah, blah. Ask the server, and the server goes back and gives it everything. That's the normal way on how it works. Now, service workers comes in and sits right in between. Now, it's very hard to find an icon for service workers, so I use this one. But what it does is, it sits right in between, and you can configure everything of the service worker. You can say, okay, only give offline files, or only ask everything from the server. So every time now the browser asks something from a server, the service worker goes like, oh, I already have 75% of all the files you requested. Here are they, immediately. I got them stored on your own local drive. And then the other 25 files, you can then ask from the server. But that's like a huge update on how good your caching will be working. Now, that's just the conceptual part. The technical part is for not. I'm not even going to try it. So why would you do it? Huge speed performance. All of a sudden, all your assets that you kind of use now and then, you have them instantly after the first page load. So as soon as the second page load is, you have them instantly, which is amazing. You have a huge caching control. You can define everything in there, and you basically control the network layer, which is awesome. Now, there is a road to background sync and push notifications, and those road, I mean, you have the capabilities, I believe, for background sync and push notifications. So as soon as you implement those, you can kind of tell your client he doesn't need this app anymore. He has been throwing money at. Now, it's offline first, which is kind of the new mobile first, I think. It works very well on flaky internet connections because everything is still instant. And you see internet as an enhancement. Now, for who is this? Every project you're currently thinking of. You can just implement it everywhere because it's caching. At its lowest form, it's just caching. And for Drupal, this means there is a module developed by Node for Drupal 7 and Drupal 8, but I think it only works for Drupal 7 at the moment. Well, yeah. So, how does service worker work? This is for Node.
Sorry. So what are progressive web app made of? So progressive web app is the term used by Google to advertise service worker to marketing people, basically, and it's like HTML5. Lots of technology under the same term. So to have progressive web app, you need a manifest.json file. This is a file that will make the OS integration of your website into Android for now. And also you need ES6 because of new APIs that you use inside the service worker and the actual service worker. Yeah, so the problem we have with websites is that we can't control how it looks inside Android or inside an operating system. We have no control on the browser cache. So sometimes you open a page, you hope that it will still be there when you open it back and you're offline. So it opens up and then try to refresh itself and the page is gone. So I don't know if that already happened to you, but it's pretty usual. And the API we have right now in ES5, they're pretty hard to work with. It's not really consistent. There are a few weird things going on. So we need to fix all of that to be able to use Service Worker and make progressive web app actually successful. So some of these new APIs, the manifest file, we'll talk more about that later. The promise in JavaScript, who heard about that? A few of you. So there's a couple of slides about this, so we can talk about it. So we have new tools like to handle URLs, URL parameters as well, because that's a bit tricky to work with usually. Fetch, which is a huge improvement over XML HTTP request. The caches object that actually provide the service worker cache for you to interact with. Then the request objects, response, header, so to kind of interact with the networking layer. But fetch is really the most amazing one. So the manifest file, we'll talk about that. Okay, hang on. I stole that from another presentation, so. So it provides all the metadata for OS integration. Yeah. So the way to define that is to add the link meta tag in your header, well, in the head of your web page, and points to the manifest.json file, which, you know, like its name says, it's a JSON file. These are all the available keys that you can configure inside this file, and we'll see what each of them does. So let's say this is your mobile website. So the first thing that you can configure is the name. So when you bookmark this page, the name of the bookmark comes from this manifest file. So you have a short name to make it nice and look good on your home screen. You can configure the icon that will be used for your shortcut as well. You have different sizes, so I don't know if you ever implemented some Apple, you know, shortcut for icons. You have like 20 meta tags. It's horrible. So this is going to replace that, you know, at some point, hopefully. You can configure the color of the title bar inside the list of apps. When you open your shortcut, you have a splash screen, so something that that is well done in apps but doesn't exist in websites, basically. So this is just a way to give time for the browser to start up and display your page. You can configure the icon, the background color, and the name. So it's on purpose, it's very simple, and there's not much to configure because it's not supposed to stay long. You know, it should be fast to display and open, so nothing much to do there. You can configure the way it looks as well, because if you have kind of an application more than a website, you probably don't want the URL bar or any of the browser UI on your website. So you can remove it by saying that the display mode is standalone. That way you only have the taskbar at the top of Android. If you want full screen, you can get full screen. And if you just want the website as usual, you put as a browser. All right. You can target a specific display mode with CSS. So if you want to change something because it's full screen, you can do that. Just regular media query. You can define the orientation of the page. So if you work on a game, for example, you can say it's landscape all the time, and that will open like that. And to keep track of who opens your website with this shortcut instead of Google or something else, you can add something to the start URL. And this will be the URL that's open when you click on the shortcut, basically. And so one of the really interesting thing about all of this, so if you have a manifest file and service worker on a website, if you go back to the website a couple of times, you start to get like a pop-in that say, do you want to install this website on your phone? And this will automatically create the shortcut. There's nothing to download because it's a website and it's already in your cache. So we just add the shortcut and it's installed. All right. Oops, sorry. Yeah, don't have time for questions, so. So about ES6, the first thing that we're going to see is fetch. So fetch is a replacement of XML HTTP requests. It's lower level, but it's simpler at the same time. So this is how you do a regular XML HTTP request. Nothing fancy. You have an error callback, a success callback, and you do something with the data afterwards. The same thing with the fetch function. It's much simpler, I guess. So it's not exactly the same, but it's pretty much the same for all intent and purpose. So first you request some ajax.json file. You wait for it to come back from the server. Then you parse the response to JSON. And once that's done, you can use it to do something else. And if there's an error somewhere in the request, you can catch it and do something else. And say, OK, that failed, try again. Fetch accepts either a string or a request object. And this request object can be configured, like if you post something, the data for the request object is going to be in there. So promise. This is basically a way to end callback hell. So I don't know if you have like something that's done when something gets finished, and so on, and you get a huge, deeply nested, set of callbacks. You can end that with promise. And in essence, it's a future value. It's a value that you don't know if you already have or not, but with the promise, you can be sure that when it gets it, you can do something else. And once a promise gets a value, it never changes. So if you want a different value because of something else, you need to make a new promise. So just some terminology, it gets fulfilled by a value and rejected by an exception. So there's two states for the promise. It's either OK or not OK, basically. So we've seen how to use it quickly with fetch, so then catch. To create yourself a promise, it's pretty easy. It's just, you call the promise constructor, you pass in a function that accepts two parameters, the reject and the resolve and the reject function. So you do something, you do, Ajax request somewhere, and when it comes back, you resolve your promise with the value that came back. Or if something else happened, you reject the promise. And then the rest of the code that use your promise deal with what it's going to do with that. Inside the service worker, we're not going to create promises because all the APIs we use already create them for you. So we're just going to use them, basically. So not spending much time on this. Promises can be chained. So if you see the first, then it returns response.json, which itself is a promise. And this is going to be the parameter for the next then. So usually you would you would nest callback for this kind of stuff without promise, but now it just gets unnested, I guess. Any questions so far? So does the promise thing make sense? Yeah, because that's really important, because everything uses promises in service worker. So. All right. So then the cache. So this new cache is different from the browser cache. So the stuff you clear with Control F5, it's not this cache. It's a different one, and it's one we can control completely. And the way to interact with it, so if you want to get something from this cache, for example, you use a caches object and you match a request with something in the cache, eventually. So match returns a promise, so you use then on that, and you do something with the data, basically. So it returns a response object, just like fetch, so consistency. That's good. And if there's something wrong with the cache, you get an error, and you can catch that. Catch. Yeah. All right, so that's how to get something out of it, and to put something inside the cache. There's a couple of APIs as well. So you open a named cache. So you give any name you want, basically. You can choose it. You can have several caches open at the same time. It doesn't matter. We're just going to use one here. So you open it, and once it's open, you can put something inside. So it's either a response from a fetch request, or it's some random content that you want to put in there. There's a shortcut which is cache add all, which takes an array of of URLs, and it's going to put that inside the cache for you. So it's like doing a fetch and cache put. Just a shortcut, basically. So I stole most of the content for that from this article. So if you want to have more explanation about all of this, you can go there. So in essence, Service Worker is a client-side proxy. And this is why you need HTTPS, because it's really, really powerful. And you can, it's a man in the middle, basically. So you can do anything you want with any of the requests that go to that website. So this is the icon for Service Worker.
That's way better.
So to have a Service Worker, first you need to install it on your website, right? Because it doesn't magically appear. You need to say, okay, I want my Service Worker file to be used as a proxy for all my requests. It's event-based, like most of the stuff in JavaScript. So you have an install event for Service Worker. You have an activate event, for the life cycle of the thing. The life cycle is pretty complicated, so I'm not going into that. But usually what you do is that when you install the Service Worker, you also get a set of files during the installation, because then they will be available directly for the next request. So it's usually like some JavaScript, CSS that is on all pages. You put that into the install event to make sure that it's always available. So first, on your HTML page, to register a Service Worker, you're going to call the register function. And guess what? This returns a promise. So if you want to make sure that your Service Worker has been correctly installed, you can log it or do something else with it by calling then and any function. If there's an error, you can catch it as well. But this is basically all you need to say, my website has a Service Worker, and I want it to be used for all my network requests. Now, inside the Service Worker file itself, so it's a separate file, and this file has its own scope. So it's, who knows about web workers already? A few of you. So inside, it's the same kind of scope. So you don't have access to the document object inside the Service Worker. You can't interact with the DOM. Because it's supposed to be fast, so you don't have the DOM. And you don't have a window object either, because it's not a window. So the equivalent inside the Service Worker file is self. So you're going to call most of the event stuff on the self object, and add event listener, the regular way to add event listener. The name of the first event is called install, and this is where you're going to use the cache. So you're going to open your cache and put something in it. So just like we've seen before, you add the cache add all method to put all the CSS, JavaScript used on all your pages inside the cache, right? So yeah, first you listen to the install event, then you're going to request all your assets from the network and put them in the cache. And at the end, you're going to say, wait until everything is finished to say that my service worker has been installed. So on the right side, no, left side, the then after the register is going to be called once all of the cache requests have been finished, right? Because cache add all returns a promise, and until that promise is resolved, the browser is going to wait to say that the service worker has been installed. Does it make sense? Sort of, yeah. So now it's installed, but it doesn't do anything because we don't react to any network event. So right now we're going to see how to just do like a transparent proxy, I guess. So it's really easy. First, you listen to the fetch event, fetch method, fetch event, consistency again, that's good. So the fetch event has an event parameter, and you can access the original request from this event object, and you're just going to fetch that from the network. You're just not doing any caching, any logging, anything, just fetch it, and then you respond with that fetch promise. Right? Make sense? So, I mean, this is useless, doesn't help you with offline, because there's no caching. So now we're going to see in 2 minutes, that's going to be tough. So now let's say you have no network, you're offline, but you still have a few things in your cache. So first, you try to look, oh wait, that should be in 2 steps, but okay, so the purple step, the 2, you fetch from the network, right? That's, we've seen that. But because you're offline, the fetch request is going to fail. So this is a promise that gets rejected, so you catch the failure, right? So you put a catch afterwards, and that means you can't get anything from the network, so you're going to look inside the cache and try to match the request with something in your cache. And you're going to return that. And you're going to return that for the browser to display. So everyone follows? Yeah? And this is how you're going to start having offline capabilities. Okay, so yeah, I don't really have much time, so we can see that after the session if you're interested, or you can look at the article as well. But quickly here, yeah, that's messed up as well. At this step, you first look inside the cache. If there's nothing in the cache, so if the cache request fails, you catch it and you look, in the network, while you fetch from the network, and then you return whatever you got, either the cache or the network request. And yeah, that's it. And if you don't have network and your cache is empty, you're going to return a default offline page that you already cached at the install step, right? So you're sure this one exists because you put it at the install. So this is how you can, click on a link on your website while being offline and not get the Chrome dinosaur stuff. You just get an empty page with whatever you want inside of it. Actually, there's a few, like some newspapers started implementing service worker, and on those kind of page, they put a list of everything you have in your cache. So everything that's displayed on this page, you can actually read because you have it in your cache. Yeah, I mean, all of this is very new, so there's no defined way to handle all of this yet. Yeah, then stale while revalidate. So basically, you you request from the network, you put it in a cache at the same time, so that if you're offline next time, you get the previous version of the page. So you always have something, but it might be outdated if you're offline. But it's not empty, at least. So I'm not going to go through that. And quickly, so background synchronization, we've talked about. So once your service worker is registered on the page, you need to register a background sync event. And you register with a tag. And once, once in a while, once you get back online, the browser is going to call those sync handlers and do something with it. So usually you put all the data you want to use in your sync action in IndexedDB. So because you can't use local storage because it's a DOM thing, you have to use IndexedDB to, let's say, save data to process during synchronization. Once again, not much time for this, but it's possible, right? So basically, you write a comment while you're offline, you save it into IndexedDB in your browser, and when you get back online, the sync event is going to be called, and you can process this comment by sending it, to your API that saves comment. And you have notification as well, so push notification. So for that, you need a separate server that handles the notification, but it's the same principle. So first, you need to request permission to the browser to display notification. Oh yeah, sorry. And then you handle that in the service worker. You prepare it, the title, the content, and you push that to the browser that will display it. And that's it. Yeah, sorry, we're a bit short on time about the demo. But yeah, let's see how it goes.
So I see quite a few computers. So I was thinking about, instead of doing a demo myself, you can do the demo. So it's less embarrassing for me if it doesn't work. So if you want, you can follow along, tiny URL, or type this ginormous monster in. Gonna leave it there for a while. This site is gonna stay up for at least another week. So basically it's a platform where we work, it's called Poshik, and it's some sort of an Airbnb for dogs, or for animals, or for pets. Now, we installed a service worker there, and we made it so yesterday that only logged in users have their, only logged in users have a service worker installed. Now, this is the cool bit. So I recorded the video to make it really, really easy. So basically you go to there and you type in, can you read that? Yeah, you can. Type in the website. You have to be going to the HTTPS version of it. Otherwise it won't work, because service worker works HTTPS only. Now, you go to the login page, blah, blah, blah. Now the user is PWA, and the password is PWA. So 2 times. Now, I'm going to refresh now to show there's no service worker now. So when you type everything in and you log in, you're going to see a service worker appearing. Now, service worker appears and it's installing now. And what we did is we configured it so that as soon as you click on, as soon as you log in, the service worker in the background, this blows my mind when this actually worked yesterday. What it does is it goes to every link of the main menu in the background, and it caches everything it can find. Basically, we cache the whole app, the main pages, for that user, as that user. So what happens is, it's installing, it's activated, and it's running. So it cached now everything. Now, when you open that Cache storage, ooh, very poor quality. Ooh, all right. Believe me, if you open the cache storage, you should be following along, by the way. And you look into that cache storage, you will see all the pages that actually went through to cache. So there are about 44 things it cached, and that's basically all the URLs for the assets and all the things we went to fetch the first time it logged in. Now, we just went to messages page, and that's an overview of all the messages the user is currently having. Pretty simple page. Now, the cool bit now is you can still browse around like any other website. It's basically all still an enhancement. But if you now go offline, and I had to do it in here, so basically you turn off your Wi-Fi. This blows my mind because it's still just a Chrome browser. I don't know if you're amazed, but I'm amazed. I don't care. I'm amazed. So if you go offline, so imagine you just turn off the Wi-Fi and you hit refresh, the page still loads, which is nuts. I just heard someone say, "Oh wow, that's impossible." No, no. The only thing we didn't cache is the images because we didn't want to bloat our own cache for this project. But you can basically cache everything you want, so you can cache the images too. But images tend to get quite big. You blow up your cache quite too fast, and users might have to clear that cache way too soon. But that's just in this project. Now, the cool bit is, you open up the menu, and you go to another link that you already visited, and it works again. Now this is an empty page. Yeah, the first page here is also quite empty, blah, blah, blah. But this browser has never seen this page. This user has never seen this page, but still it's in there, and he's offline. And now anyone can shout out what is the difference between an app and a website. Now, there isn't one. So this is so cool because it's actually offline. Now there are some limitations, as I'm going to show here. For example, if you now go to messages, and we're going to click on this in a second, you go to the message detail page. The service worker wasn't able to cache that page because the user will be able to go anywhere in the website. You can't cache everything on the website. So we're still offline, and now we clicked on the detail page, and now it's going to go like, okay, but we don't have this, so you're offline. But you still have the menu. You don't have like white dinosaur that you have to jump around with. You have an offline default fallback page.
But what if I want to?
Yeah.
You can program that. Yeah, and then you can cache the dinosaur. Now, the cool bit is now, if you go back online, so this is a real edge case, you know? If you go back online, no, it's not an edge case, really. If you go back online, you hit refresh, page is gonna load again, because the user got notified, oh, I'm actually offline, I didn't know. Weird that this website is working all this time. He reloads, he caches the page, and then the service worker now goes like, oh, this user loaded this page extra, and now it actually cached the page also. So now it goes, you can't see it in here, but it's somewhere over here. Here, this page. Which is pretty cool because now I'm going to go back offline. I'm going to go back to messages. This is still, again, offline cached. I go to the detail page, and it's there because it has the URL, and it cached that URL. And if you go there, this is the last time you saw this page, so you still have it. She's nuts. It's nuts. Now, the only thing, this demo is going to go on for a bit. I'm going to show the same thing with a profile, detail page, but it's all the same stuff. Now, the cool bit is, let's say the client goes, yeah, but my client is actually going to watch this video, so hi. So Patrick, and he actually said, like, we don't give a damn if this site works offline. He doesn't care, which was quite sad, but he has kind of a point. Users want something to download. They want to go into an app store, they want to download something and then go like, huh, I just installed something on my phone, I have it. If you're going to throw a website at a user, they're not going to be able to know that it works offline, not in the beginning at least. So maybe you do want an app, or maybe you want a sales pitch that you want to go like, hey, can I work with service workers? But yeah, I'm going to throw away the current apps we have. So I went one step further, together with Swentel. I'm not sure if he's here. No, he's not. And I went like, okay, let's have the website that works offline and just encapsulate it with a Cordova or a Java. I think it works with Java. And then it kind of works like this. You have now an app, and what it does is just, you click on the app, and it's a web view. So it opens up the browser without the browser header, and you have an app. And all of a sudden, we created an Android native app with 10 lines of code. Just nuts too. Now, the only bad thing about this, I have to mention that Safari is not, and that's the last thing, and then maybe one question or something, because we really don't have any time. The Android, this is brilliant for Android, because Service Worker works on Chrome. Android uses Chrome. Now, you could say, oh, but on iOS, you can't use this, because Safari doesn't support it. And then you can make the comment, yes, but you can download the Chrome on iOS. That's not entirely true. If you download the Chrome on iOS, basically what it does, it downloads a masqueraded Safari, because iOS doesn't allow anything else than Safari browser on their platform, which is kind of very sad, because now we can't build this native application on iOS. And also, if you could do this on iOS, the App Store would probably say, this looks a bit too googly, so we don't want this. So, yeah. So, the very cool bit is, if you use progressive web apps, so the whole Service Workers approach, as a progressive enhancement, this is going to be brilliant to work with. But if you're going to rely on it, we're going to have to wait on Safari. Now, they did mention that they have a 5-year plan where they are kind of thinking about it. It's quite sad. But yeah, it's the current status of it. So the last thing is, we're also organizing Frontend United in Greece, the end of May. I looked it up, it's going to be brilliant weather. Be there. We already have quite cool speakers like Lea Veru and Snook, the guy from BAM, the guy who wrote, Smacks, the guy who wrote Smacks, not BAM, and Rachel Andrew. So that's it. If we have, what?
Do you have an app?
Yes, we do. Not yet, but we will. And that's it for now. So thank you very much, and I don't think we have time for questions. No, we don't. Maybe in person.
We can cache the card.
Oh yeah. Thank you.